table of values. Now, table of values is a list of numbers that are used to substitute in one variable within an equation and or a function to find a missing number or...
For our first example, in the table of values, we have the limit of x plus 2 as x approaches to 3. We have the x and f of x. X values are the one who are we substituting to the given equation. And the f of x are the answers. These approaching values should be closer to c, which is 3, but not more than 1 unit. So, on the left side, which is less than 3, we have 2, 2.2, 2.4, 2.6, and 2.8. And on the right, we have 4, 3.8, 3.6, 3.4, and 3.2. So we will substitute the x values in the equation, which is 2 plus 2, 4, 2.2 plus 2 is 4.2, 2.4 plus 2 is 4.4, and 2.6 plus 2 is 4.6, 2.8 plus 2 is 4.8. And on the right side, we will do the same. 4 plus 2, 6, 3.8 plus 2, 5.8, 3.6 plus 2, 5.6, 3.4 plus 2 is 5.4, 3.2 plus 2, 5.2. And they are going to 4.8 and 5.2 is going to what number? Yes, you are correct. It is 5. And limit of x plus 2 as x approaches to 3, and the limit of it is 5. So for the second example, we have the limit of log x as x approaches to 1. So just like the first example, we will substitute the x values in the given equation. We have log 0.2, substitute to x. Log 0.2, and the answer is 0.69. For the second one, we have log 0.5. We have the answer 0.30. For the last, log times 0.9. Answer is 0.04. And for the right side rather, we have log times 1.9, and the answer will be 0.28. And for the second one is log times 1.5 is equals to 0.17. For the last one, log times 1.2 is equals to 0.07, which means limit of log x as x approaches 1, and the limit of log x as x approaches to 1 is 0. So for the last example on the table of values, we have limit of e raised to x. We will substitute the x values in the given equation. E raised to negative 1. The answer will be 0.36. And next one, we have e raised to negative 0.5, and the answer will be 0.60. And the next one is e raised to negative 0.2. The answer will be 0.81. On the right side, we will substitute e raised to 1, and the answer will be 2.72. 0.5 e raised to 0.5 is equals to 1.65, and e raised to 0.2, 1.20. Both values are approaching to what number? 0.81, 1.20. The answer will be 1. Limit of constant theorem. Limit of constant theorem defines as limit of given constant as x approaches to any constant is equal to the given constant. For example, limit of 5 as x approaches to pi. The answer is 5, because the rule says that the limit of the constant is always equal to the given constant. 5 is our given constant, so that 5 is the answer. We have two another examples for the limit of constant theorem. First one, limit of 20 as x approaches to log power 10. The answer here is 20. Simply because the rule states that the limit of the function is always equals to the given constant. The given constant here is 20, so that our answer is 20. Next one, limit of 30 as x approaches to e raised to 10. Answer here is 30, because it satisfies the rule of the limit of constant theorem. 30 is our given constant, so that 30 is our answer. Limit of function x. Limit of function x is defined as the limit of x as the x approaches to any constant is equals to the given constant. For example, the limit of x as x approaches to 5. The answer here is 5, because the given constant here was 5, so that 5 is our answer. We have another two examples here. First one, limit of x as x approaches to pi. The answer here is pi, because the given constant here was pi. So that pi is our answer. Just like the first one, limit of x as x approaches to log raised to 20 is equals to log raised to 20, to satisfy the rule that the given constant is equals to the constant. Given constant is equals to the constant. Limit of constant and a function of x. Limit of a constant and a function of x is defined as limit of given constant and a given function as x approaches to any constant is equals to given constant multiplied to the limit of function of x as x approaches to any constant. Example of limit of constant and function of x is limit of 3x as x approaches to 2. First, we will separate the two terms. Limit of 3 as x approaches to 2 and limit of x as x approaches to 2. Now, we will apply the first rule here. Limit of constant theorem. The constant here is 3, so we will put down 3. The second one, we will follow the rule number 2. Limit of function of x. The constant given here was 2, so we will bring down 2. We will multiply them, then we will get the answer 6. Another set of example with the limit of constant and function x. First one, we have the limit of 4x as x approaches to 1/2. First, we will separate the two terms. Limit of x as x approaches to 1/2. Just like the first example, we will apply the first rule, which is constant theorem. The limit 4 as x approaches to 1/2. The limit constant here is 4, and the other term we will use the second rule, which is the limit of function of x. We will bring down 1/2 because 1/2 is the constant on the second term. So we will multiply them. The answer will be 2. The other example, we have limit of 5x squared as x approaches to 2. We will separate the two terms. Limit 5 as x approaches to 2, and limit of x squared as x approaches to 2. First rule, constant theorem. Constant here is 5, we will bring down 5, and the other term, the rule of function of x, we will the constant given on the second term is 2, but the x there isn't squared, so we will square the 2. The answer will be 4. So 5 times 4 is equals to 20.
So, the limit of sum and difference of a function is defined as the limit of the two given functions as x approaches to any constant is equal to the limit of the first given function as x approaches to any constant added and or subtracted to the other given function as x approaches to any constant. Now, to fully understand the rules of sum and difference of function, we have to apply it into a problem. We have to find the limit of x minus 4 as x approaches into 1/2. First, we have to separate these two terms. Limit of x as x approaches into 1/2, copy the sign minus limit of 4 as x approaches into 1/2. Now we have to substitute the x into 1/2. Minus 4 is equal to 1/2 is minus 4 over 1 is equal to 1 minus 8 over 2. The final answer is -7 over 2. Now for the next problem is to find the limit of x plus 5 as x approaches -2 is equal to, separate the terms, limit of x as x approaches to -2 plus limit of 5 as x approaches to -2. Now substitute the x into -2 plus 5 and the final answer is +3. Now for the last example is to find the limit of 4x plus x as x approaches square root of 2. Again, we have to separate these two terms, limit of 4x as x approaches to square root of 2 plus limit of x as x approaches to square root of 2. Then next, we have to substitute x into square root of 2. 4 is square root of 2 plus square root of 2. And we know that we have an invisible number 1, so 4 square root of 2 plus 1 square root of 2 is equal to 5 square root of 2. So, the limit of a product of function is defined as the limit of two given functions as x approaches to any constant is equal to the first given function as x approaches to any constant multiplied to the next given function as x approaches to any constant. Now, to To apply the product of functions, we have to solve a given problem. We have to find the limit of 3x multiplied into 5 as x approaches 1. Separate the two terms, 3 limit of 3x as x approaches 1 multiplied into the limit of 5 as x approaches 1. Substitute x into 1, 3 multiply into 1 times 5. Now 3 times 5 and the answer is 15. For the next example, we have to find the limit of 5x multiplied into 2 as x approaches the square root of 4. We have to separate these terms. Limit of 5x as x approaches the square root of 4 multiplied into the limit of 2 as x approaches square root of 4 is equal to, substitute x into square root of 4. Now in this part, the square root of 4 is equal to 2. So 5 multiplied into 2 times 2. 10 times 2. And the final answer is 20.
Limit of a quotient of a function. The definition is the limit of a function divided by the given function as x approaches to k is equals to limit of a function as x approaches to k divided by the limit of another given function as x approaches to k, provided that g of x must not be equal to 0.
For our first example on limit of quotient of functions, example number 1, we have limit of x over 5 as x approaches to 5. Separate the terms, limit of x over as x approaches to 5 over limit of 5 as x approaches to 5. We will use the function x and constant theorem here. We will get 5 over 5 that equals to 1.
Is equals to limit of x as x approaches to 5 over limit of x as x approaches to 5 minus the sign is subtraction, so we will also use the sign subtraction. Limit of 5 as x approaches to 5 is equals to 5 over 5 minus 5 equals to 5 over 0. In the limit of quotient, g must not be equal to 0, so the answer is d and e, or does not exist. Therefore, the limit of x over x minus 5 as x approaches to 5
For our final example in the limit of quotient of functions, we have limit of 5 over square root of x as x approaches to 8 is equals to limit of 5 as x approaches 8 over limit of square root of x as x approaches to 8. Bring down by applying the rule of constant function, and function x we will get 5 over square root of 8. But in the rules of radical, there is no fraction form. So we will multiply it to the square root of 8 in both sides, and we will get the answer 5 square root of 8 over square root of 8 square. So we can cancel the radical sign, and we will have an answer like this, 5 square root of 8 over 8. But square root of 8 has a factor form, which is 4 and 2. And 4 is a perfect square, so we will bring it outside, and it will become 2. 2 square root of 2. And multiply 5 times 2 square root of 8 over 8. The answer will be 10 square root of 8 over 8, and 10 and 8 can be divided into 2 to be simple form, and we will get the answer 5 square root of 8 over 4.
Limit of power of a function. Definition. Limit of a function as x approaches to k raised to the power of n is equals to overall limit of a function as x approaches to k raised to the power of n.
Example number 1. Limit of 3x squared minus x as x approaches to 3 is equals to 3 times the limit of x as x approaches to 3 is squared minus limit of x as x approaches to 3 is equals to 3 squared minus 3. 3 times 3 squared is equals to 9 minus 3. 3 times 9 is 27 minus 3. 27 minus 3 is 24. And that's the final answer. Example number 1. Limit of the square root of x over x squared as x approaches to 2 is equals to the square root of limit of x as x approaches to 2 over limit of x as x approaches to 2 is squared is equals to the square root of 2 over 2 squared is equals to the square root of 2 over 4. And that's the final answer.
For our last example in limit of power of function, we have the limit of 4x cubed minus x over 7 as x approaches to 4 equals 4 limit of x cubed as x approaches to 4 minus limit of x as x approaches to 4 over limit of 7 as x approaches to 4. By applying the fundamental theorems, we will get the answer 4 times 4 cubed minus 4 over 7. And we will simplify it 4 times 4 cubed, which is 64, minus 4 over 7. And 4 times 64 is 256 minus 4 over 7. 252 over 7. And it can be simplified to 36.
Limit of a root of a function. Definition. Limit of a n root of a function as x approaches to k is equals to n root of a limit of a function as x approaches to k.
So for our first given function in the limit of root of function, we have the first example, limit of square root of 3x squared minus 2x plus 8 as x approaches to 2. So our first step is separate the three terms. Limit of 3x squared as x approaches to 2 minus limit of 2x as x approaches to 2 plus limit of 8 as x approaches to 2. Next step, we will apply the constant in a function of x on the first term minus the as well as in the second term limit of 2x with as x approaches to 2. That's why we will put 2 on the beside of 2 plus 8. Bring down again 3. Limit of x as x approaches to 2 is on square. That's why the answer is 4. 2 square is 4. Minus 4 plus 8 is equals to square root of 12 minus 4 plus 8 is equals to 8 plus 8 is a square root is equals to square root of 16. That's why the square root of 16 is 4. So for the second example in limit of root of function, we have the limit of square root of 2x squared minus 2 overall square root of x as x approaches to 2. We will separate the two terms, limit of 2x squared as x approaches to 2 minus limit of 2 as x approaches to 2. to 2. Overall square root of limit of x as x approaches to 2 equals 2 limit of x squared as x approaches to 2 minus limit of 2, which is 2 overall square root of 2. Third step. We'll combine these terms, and 2 times 2 square minus 2 over square root of 2. The answer should be like this.
Square root of 8 minus 2 over all square root of 2 is equals to square root of 6 over 2. We will multiply them to the denominator of the first term as square root of 2 to cancel them out. So square root of 6 times square root of 2 is equal to square root of 12 over square root of 2. So we will square that, so we will cancel the radical sign, and so the answer is square root of 12 over 2. So for the last example and limit of root of function, we have the limit of square root of x squared plus 2 as x approaches to 4. We'll separate the two terms, limit of x squared as x approaches to 4 plus limit of 2 as x approaches to 4.
By applying the rule of function of x, we will get 4 squared because of the rule of function of x plus 2 on the constant theorem. We'll get square root of 16 plus 2 is equal to square root of 18, and square root of 18 can be factored out, and 9 times 2, and 9 has perfect square, so that